All right, now I'm going to be giving you a chance to practice one of these. Now, practicing these is a little different through the video method. So how we're going to do this is I'm going to have you watch that side video again about what are the steps you want to do. And then we're going to come back and I'll say, hey, pause the video and see if you can figure out what smooshes together. And then I'll show you what to do next. And then, so if you just want to watch, you can, but I'd like you to kind of pause, try stuff if you get stuck. Keep watching the video kind of thing. All right, so here we go. Let's watch that side video and figure out what are those steps we need to do to figure out what's going to go together first. So you need a refresher on the rules. Let's refresh them quick. If you don't, just skip ahead a little bit. So when we want to reduce a circuit, we want to smoosh those parts together. The first thing you need to do is draw your circuit, identify your nodes. Your nodes are these places where you have 3 or more wires coming together. So identify those nodes. I like to just circle them in green here on the board. Step 2, you need to look for series. So yes, I say step 2 and step 3, and it is this order very much. Always look for series first, parallel second. So we're going to look for series. Series is when I have multiple resistors between nodes. So I might take this upper path and I hit 1 resistor, 2 resistors before I get to the next node. Yes, those two are in series. When I go down this path, there is only 1 resistor along that path, so that is not a series. So whenever I identify a series, I need to combine or smoosh those together. So I would take those top 2 and I need to smoosh them together into a single resistor. Whenever you smoosh, whenever you combine, you always want to go back to step 1. You want to redraw that circuit. Identify the nodes. Some of those nodes may have disappeared, and they definitely will disappear when you're doing parallel combinations. So you go back to step 2. Are there any multiple resistors along a single path? Nope. The reason I say is do step 2 again. Sometimes you miss a couple. So sometimes there might be 3 resistors in series. You only saw 2 of them. So just go through that one step again. Step 3, we're looking for parallel this time. That means we're looking for multiple paths with only 1 resistor per path. And this is between nodes. So when I go from this node to this node, I can either go up, only 1 resistor on that path. I can go down, only 1 resistor on that path. In that case, those two are in parallel, so I need to combine or smoosh them together into a single resistor. All right, so now that you watched the side video, let's go ahead and see if you can identify those nodes, figure out which types of circuit components I have here, what resistors are going to smoosh together first. Give it a shot. All right, so you've given it a shot. So let's go ahead and do this and see if you got the right answers. So these are our nodes, any place where you have multiple kind of wires connecting together. You'll notice I have 1 resistor per path between these 2 nodes. So yes, these 2 resistors right here are going to smoosh together in a parallel. And these 2 are also going to be in parallel. So if you identified that, good for you. You now have 2 parallels that you're going to kind of smoosh together first. So let's go ahead and see if you did that right. So you redrew it. And after you redrew it, you kind of did your values that you got through the parallels. So because they were in parallel, you were adding their inverses. So a third plus a sixth is a half. The inverse of a half is a 2. So you should have got 2 ohms here. And you had a 12th plus a 4th, which is a third. The inverse of a third is 3. All right, thinking about that side video, see if you can figure out how those 2 go together. If you didn't pause it, pause it. All right, now you figured out how these go together. You notice that they are multiple resistors along the same path, so I have a series. So we're going to go ahead and put them together with a series. And you add them as if they were just numbers. So 2 plus 3 is a 5. And so we get to the end here, and we have a single 5 ohm resistor on our 60 volts. All right, so if you'll remember in the example problem, the next step we did is we worked backwards. So I want to see if you can figure out how to work backwards through this, okay? So first thing, again, you got to find that total current. And then whenever you see series, you're going to have same current as the one that they smushed together to be. And whenever you have parallel, same voltage. All right, give it a shot. I'm going to all of a sudden do this snap thing, and all the answers are going to be on the board for you to check yourself. So hit pause, and then I'm going to fix everything. All right, we got it all done. So let's check our answers here. So the first thing you needed to do is find the total current of 12 amps. Once you found the total current of 12 amps, because we combined series the last time, we are going to bring back the same current that we had here for the smooshed components, 12 amps. So both RA and RB will have 12 amps moving through them. We can figure out the voltage in each one. Those two voltages should add up to the total voltage of 60 volts because it is a series, the voltages add. All right, now the next step, we go back through parallel. Now this might be hard to see, so I'm going to, in just a second here, I'll zoom in and kind of take a closer look at this for you. So we should see that when we go back from B through parallel, we should have the same voltage as B, which is 36 volts. So the two that smooshed together to be my RB here were 3 and 4, so they will both have 36 volts. And then I can find their individual currents of 3 amps and 9 amps, which is a total of 12 amps. Correct. And RA was combined through parallel, so we're going to bring back the 24 volts to what combined together to be RA, R1 and R2. So using that 24 volts, we can find their currents of 8 amps and 4 amps. And together they make 12, so it checks out. So let me zoom in on this quick for you so you can see it a little better. All right, there you go, a little closer look for you. Again, if you have any questions, by all means, check out office hours.